Hi, this is Teacher Eliasar from Learning Math Academy. Making mathematics simple is our top priority. So today we're going to have a short discussion. It's all about the set of real numbers, which is very important in order for us to learn more topics about algebra. Okay, but before we describe the set of real numbers, let's be sure you are familiar with basic ideas about sets. A set is a collection of objects whose contents can be determined. The objects in a set are called elements of a set. For example, the set of numbers used for counting can be represented by this. Okay, so we have 1, 2, 3, 4, 5. Then we have 3 dots. So we are going to recall what's this all about. So we have here braces. This one and the other one. So braces indicate that we are representing a set. The form of representing a set uses commas to separate elements of a set. So we use comma in order for us to separate the elements of a set. So this one, 2, 3, 4, 5 are elements of the set. Then we have 3 dots here, so forth and so on. So the 3 dots, what does it mean? The 3 dots are after the 5, this one, 3 dots after the 5, indicate that there is no final element and that the listing goes forever. So there's no final element for this, the set of counting numbers. And we must have 3 dots. And it goes forever. All right? So did you understand now what is a set? Okay, let's proceed to the main topic for today, which is the set of real numbers. All right, so what is the set of real number? A set of real numbers is formed by combining rational and irrational number. Thus, every real number is either rational or irrational. Okay, that's it. But let's define first what is rational and what is irrational. So when we talk about irrational numbers, these are non-terminating decimal with no pattern. So it means a number with decimal that the decimal doesn't end. No, non-terminating and non-repeating decimal. There's no pattern. No, because if the decimal is non-terminating but repeating, that is rational. We can say irrational if that decimal is non-terminating and non-repeating decimal. So example, pi. Pi is an example of irrational number because pi is equivalent to 3.1416, so forth and so on. It doesn't end, but we just end by that one, 3 rounded off to the nearest tenths. So let's proceed now to rational. So when we talk about rational number, so that is a number that can be written in a fraction form. That's why we have Q as a letter that represents rational number, which means quotient. Okay, so we are going to start from the bottom. So N. N stands for natural numbers. So what are those natural numbers? Okay, so natural number starts with 1, from 1, 2, 3, 4, 5, so forth, so on. Just like what we did a while ago. So that is the other term for natural number is counting numbers. And the letter that represents this is N, which stands for natural numbers. So next is whole numbers. So when you talk about whole numbers, that is 0 plus a natural numbers. 0 plus a natural numbers. So that is a whole number. So when you talk about whole number, zero is included. Zero plus natural numbers. So 0, 1, 2, 3, 4, 5, so forth and so on. That is a whole numbers. So next, the set of integers. The set of integers are all whole numbers under opposites. So whole numbers and all opposites. So that's what we call integers. So 0, 1, 2, 3, 4, 5, 6, 7, so forth and so on. And the opposite is -1, -2, -3, -4. So that is what we call integers. And it represents by the letter Z. Z. So why Z? Because Z stands for Zahlen. That is a German word which stands for integers. That is Zahlen. So next is rational. So rational overall, the natural number, the whole numbers, the integers, those are rational. Can be written in the form of A over B, where B must not equal to 0. And A and B are integers. So that is what we call rational. Other than that is what we call irrational number. So let's recall, the set of real number is formed by combining the rational number and irrational number. Thus, every real number is either a rational or irrational number. That's all for today. Bye-bye.